Login accepted.
Good morning, everybody. I'm super happy to be here, and I'm also very surprised that I thought I would find myself on a tech stage, and in the end, I end up in a concert hall. So I thought I get out my music, and instead I just give a concert. Everybody okay with that? No, I will not. I have a past as opera singer, so this would have been amazing. But it's also amazing to tell you about AI and Java and what we can do with artificial intelligence. So my first question for you would be, who of you uses ChatGPT or some other AI thing regularly? I don't see well, but okay, like I would say half of the people use it. Who of you uses an AI assistant while coding? All right, like 20, 30%. So today what I want to show you is what we can already do today in our coding work, but also in our applications, because we can already use it straight from Java and build things on top of AI models. And then a little peek into the future, if we are all going to be out of a job or not. Now, I wonder, I see still a lot of people coming in. Maybe I should wait a bit. Well, I start with a very nice one. Who of you likes juggling around with date and time formats in code? You? Really? Okay, 4 people in the whole room. All the rest is probably like me and wants to pull their hair out when they have to do it. So I want to show you some LangChain4j example where the LLM takes care of that for you. So LangChain4j is a framework to connect to LLMs, mainly straight from Java. It makes it really easy so you can connect to multiple providers, be it OpenAI, the ones behind ChatGPT, or Anthropic, or Azure, or the AWS models in Bedrock, or also local models, or things you run on Hugging Face, where you can even train your own models. That's just super easy interchangeable with LangChain4j. So this little example here, we're going to first create a connection to a chat language model, in this case an OpenAI chat model. And all we have to set here is our key, because in order to use it, we need a key to go to use their API. And then what we have in LangChain4j are a thing called AI services, where you just declare as an interface what you want to happen. So it's not much programming involved anymore. So this one, we call it textutils, this AI service, and it has one method, extract date time from a string. And what it gives back, and that is so nice, it gives us a real local date time object back. So we don't have to care about parsing the string that comes back. We can just continue working with our local date time. And that's the magic of LangChain4j, who does that behind the scenes for you, who forces the model to reply in a certain format and then parses it for you. So you can just continue with your Java code. And we give a user message, which is an instruction, extract date and time from it being this only variable we have here. That's all. Then we can just create this AI service with AI service.create from this class here. We pass the model because we need a model in order for this to work. The model behind this is, the default one is GPT 3.5 Turbo, which is also the one behind the free version of ChatGPT, but if you want, you can also change which exact model you pick here and which provider. Now, so we have now our AI service, and we should be able to use this method, textutils.extract datetime from, and we're going to try to extract the datetime object from this. It was exactly 3 days before St. Valentine's Day of 1998, just 15 minutes shy of noon, when a thunderstorm erupted above the beautiful city of Krakow. Actually, I'm going to make this shy of midnight, because that's about what happened yesterday, right? And then we're going to see if we manage to extract a real local datetime object from it and print it to the console. Now, let's hope that the internet connection works, because I'm making a call. There you go. That's how fast it was. And it says 1998, it's correct. 15 minutes shy of midnight, so correct. And then 3 days before St. Valentine's Day, which is on 14th of February, very important, so 13th, 12th, 11th, that's correct. So this was completely not possible to do before programmatically, to go extract these features out of general text like that. And it's one of these big strengths of LLMs that we can use today, straight from Java, as you can see. Okay, some other use cases that may prove useful for you in your daily life, just to show you a bit the strength of ChatGPT, which we all know by now. So what I will do, I'm going to ask it to give my 10 lab result values in JSON format for someone that's developing biological drugs. That happens to be the field that I work in. Just going to copy it, and I don't have to type it. Just make sure it's working. All right, and I give no more context, but I'm going to get here a bunch of basically synthetic test data in JSON format. So there it goes. Let's see if I can zoom in on this. I can't, but the screen is quite huge, so I hope you can read it nonetheless. So here I go, like perfect JSON format, because it's actually super good at creating this. And then some demo test data that I could just start using right away. Now, if I wanted to take this a step further, I have another question, a follow-up question for ChatGPT. I'm a backend developer. I'm not very good at making nice front ends, but now since ChatGPT, I can do it as well. So I'm gonna ask it, my question here, generate an HTML page where the physician can enter these, all this data and the identifier for whatever molecule they was working on. When they click submit, send it to the backend at a certain port, and then give an uploaded successfully message. I want one HTML file only with CSS and JavaScript integrated because I'm lazy and I just want to copy this thing out. So I'm basically asking for a kind of system where the physician can enter all these dates and submit them to my backend. So now this is ChatGPT coding for us. So it's writing its HTML here, is somewhere doing the CSS, and we're going to let him write. We're going to come back to this and check if it works afterwards. And meanwhile, while it codes for us, I go look at the next example. That's one where we use an LLM, a large language model, to generate SQL. And it's actually very apt at doing so. It's really doing a great job in general. So we have an example here, which is again using LangChain4j and a Quarkus framework. If you are interested in seeing these examples, they're all open source, so you can have a look inside. Let me get it running first. So that's the right one, yes. All these examples, you can find them in the LangChain4j on the README page of the project, so it's github.com/LangChain4j. And there you find them all linked. Normal examples, Quarkus examples, Spring Boot examples, so we have all these integrations too. Good. By the way, in the meantime, our HTML is ready. So we can just copy this, and I'm just going to throw that, oops, sorry, keyboard settings. Yes. I'm going to throw that in here, and then we can look at the results. So it looks okay, and I could ask it to make it a bit more colorful and everything, and a bit more fancy. So indeed, like compound identifier, I'm just going to say molecule 1, and then fill in some data. And now I hope it didn't make the fields all mandatory, and I'm going to try to submit this. Yeah, they're all mandatory. I mean, now I can ask follow-up things if certain things have to be mandatory or not, and it can go edit. So ChatGPT can go edit that code for me, but it's working pretty smoothly, and it should also send this to our backend. We're going to have a look at the JavaScript coming out of this in the end. Yeah, so it's going to send this exactly to where I asked it to send it. So that's really helpful for getting started with small things, and also for working with things that you're not so good at. Good. In the meantime, we have our Quarkus example running here on localhost. I'm going to make it a bit bigger. And so what it does, it has a movie database in the backend with annotated movies that contains a lot of information about them. And then there's this chatbot here. If you like to build this chatbot for your website, here you can find this code and how you do this with the pop-up, all in this Quarkus example. And we're going to ask it, hey, we want to, and actually the typos don't matter. We want to watch a nice fantasy movie from the 90s. And so this is not just going to any model that's been trained to, I mean, any model could probably answer this because they've been trained on all that data usually. But this one has also a SQL search behind it that searches in our database. So it recommends the matrix, very nice, which is indeed from the 90s. And we can go observe what it actually used to find this. So here you see the query it used. So select movie name from movie, where genre like fantasy, and then between these years. And this is correct. Yes, that is correct. So it's very nice to interact with any database and put a nice layer on top. If you let it interact with your database, be a bit careful, because if I'm in a bad mood, I can also say drop all tables. Just so you know what not to do. Okay, so it was prompted to only answer about movies, which is smart. Anyway, when you build a chatbot, make sure you tell it to only answer certain topics. Otherwise, people can just start using this as a free ChatGPT, basically. Yeah, and it didn't want to. But if I was smart enough, I could make it too. So be sure you put some checks in place before you build these things for real. Good, and like a general thing with LLMs and with AI models is start thinking meta. Because LLMs can generate code for you. It's not going to be perfect, usually. There are going to be some bugs. But they can also write the unit tests to check if the code actually works. The unit tests are not going to be perfect either. And then you're going to run into some errors. And then you're going to see, oh, here the test is wrong, or oh, here the code is wrong. But like altogether and with some iterations, you get really, really good results. LLMs are smart enough, they can give you an answer. They can sometimes hallucinate an answer that's not correct and that they just invented. But then they can also go check themselves if it's true, or if the solution is good, or which would be the best approach in the end. They can generate steps that should be followed, and then they can actually call LLMs to perform these steps, step by step. And then in that way you can obtain things that would usually be too complex for it to do, but since it can create its own steps and then execute them, it can still manage. And they can also decide whether an LLM is actually the right tool to answer the question or to perform the task. So what you see in the image here is something that's also integrated in LangChain4j. It's called Advanced RAG, where the user has a question, and probably the data is not in the training data set. For example, it's too recent. For example, ChatGPT is trained until up into 2002 somewhere, and a more recent event, it doesn't know about it. Or there's things in your database that it was never trained on, but you would want it to know about it. Then you can go search extra information that would be relevant for the answer. And that's where you can have a query router where LLM itself can decide, oh, should I go look in my database to find the answer? Because I know the database scheme, so I know I will find it in there, and I will write a query for it. Or should I go look on the web? Is this something recent or something that's not in my database? And then it will write your web search query also. Or it can do a semantic search, which is the typical retrieval augmented generation for the ones who heard about it. It goes search things in your documents that resemble the meaning of the question. So that might be very relevant. And the LLM itself is also smart enough to route this. So we also, even in LangChain4j, have something that says you can call any tool as long as you manage to write the JavaScript for it yourself. And then the LLM writes the JavaScript for whatever it wants to be seen done, and then we run the JavaScript for it, and we give the answer back. So it's extremely meta what you can do with it. Now, there's a lot of issues with AI and large language models. So they are being worked on. So everybody says, okay, it's hallucinating a lot. It was, it still is a bit, but people are working on things like source annotation to know where the information came from, or double checking, or indicating what's less sure and what is more sure. There's so many scientists at the moment on these topics that I am sure they will get solved. Another thing, for example, is this model size. They went down a couple of order of magnitudes already compared to 2 years ago. So what you see here on the graph are some open source models and their size. And as you can see on the left, yes, on the left, you have Phi 3 Mini there and Llama 3 8B. These are 2 open source models that you can just download, and they're like a couple of gigabytes. Like the Phi 3 is 3.5 gigabyte big, just to download the entire model. And then you can run that locally on your computer, and it's performing almost as good as GPT 3.5. So it came out about a month ago. It's Microsoft that released it. So as you can see, there's huge progress going on in the field. So I would say think big when you think about AI. Maybe some things cannot be done today, but it's coming. It's really coming at an incredible speed. Good. So this was a bit an intro to make you feel what you could do with it. I'm going to dive now more into detail. How does AI actually work? Just a quick overview so you know what you're dealing with. How can it help you for developing software? Then how, things to watch out for, very important. Then how can you include it in your software, build applications on top of it, and then what would the future hold? Even though it's hard to predict, I must say. I am Lize. I'm a software developer, a Java one, just like most of you, I guess. I work for a bioinformatics company where we make software to speed up drug development and gene therapy. I'm head of AI there too, so that's quite exciting. I'm also collaborator of the LangChain4j framework, which you may have noticed, but I'm very enthusiastic about that. And I'm also an AI transition consultant at OpenTides, where we help companies choose how to best move on, how to best use AI for their use cases, be it for internal process optimization, automation, or for how they can add AI to their product or even create a new product based on it. So let's dive into how AI actually works. What you see here is a neural network architecture. There's different flavors of it, but they all boil down more or less to something like this. You have layers. Nodes, the input nodes still represent something, say pixels, in case you send in an image. The output nodes represent something, say the category of what you see in the picture. And in the middle, it's pretty much a black box. And the way then we train the weights, that's to go from one node to another, is that we're going to throw a huge training data set at it from inputs and desired outputs. And in that way, the paths that are most successful are going to get higher weights. In a very similar way like our brain works, the things, you're trying out things, and some have a negative result, some have a positive, and then you have this reinforcement. It's also working the same way with our synapses in our brain. So you don't have to really define rules for this to work. You just have to pick an architecture, and then it will kind of find the rules out itself in these weights. And then you have, once you have these weights, you have what we call the model, or trained model, and this is no more than a calculation scheme. So if you wonder what's happening when you really just call a model, in the end it's you send in some digital input, it runs through a lot of matrix multiplications, as you can see here, and it comes, and at the end of all the calculations comes out something else that you want to use. You can send in anything that you can think of. So images, text, that are the typical ones, voice recordings, but also like, say, a heat map or whatever, microscope image, anything you can think of that you can digitalize. You can also get out of it anything you can think of. If you train a model to do so, it will do so. So are running AI models, is it dangerous? Is there a data privacy issue? No. But it's the way that the whole tool is wrapped. So we typically use it as software as a service, where, for example, ChatGPT is one of those examples, right? They run it on their servers, and you don't really know what they do with your prompt, with your question, or with the output, or if they're going to use whatever you send in. So whenever you use it as software as a service on someone else's server, be sure to check their terms of use, especially when you're sending customer data in, for example. Check this very carefully. You can also run models in your private cloud, but then you need a model that you can download, so an open source one. Then it's your own conditions, right? You can run it on-premise on your own dedicated hardware. Now, the hardware is quite costly, but then again, the models are getting so much smaller that these days it's actually not that costly anymore. For all the companies, I think the majority of companies that just don't want to throw all their data to some other service. Or you can even run it locally. Let me actually show you that. Now I'm at it. Wait. I seem to have lost this. Yeah. So what I have running is a tool called Olama. You can just go download it. And it allows you to download a lot of open source models. So I'm going to run this Phi3 that I was talking about. Like, if you never ran it before, it's going to just download it, 3.5 gigabyte for you. And now we can start using this. And this is running locally. I don't need an internet connection for this. So I'm going to say, explain linear algebra, and then you can see how fast this goes. So that's like almost as good as GPT 3.5. This is how fast it goes. I have a little bit of GPU on this MacBook, but it even works if you don't have GPU. It's going to be just a bit slower. Also, people are building in on-device GPU, so GPU, graphical processing units, and their variants that are really good at running these models. So voila, that's just running locally. Good. Yeah, and then to give you an idea of what's involved in training a model, there's an ecosystem called Hugging Face. They offer all the open source models and also a lot of training data that you can just use there. They have instructions how to train models and architectures, how to fine-tune, and then they offer some hosting services for you to run your trained model if you would like to. So these people from Hugging Face are doing really cool stuff. So they've put together a team of over 1,000 scientists all over the world, so a group from Hugging Face and many others to help to generate one of the first open source coding models. And you can see their progress. You can see how many tokens they trained on. So tokens is about 3 characters. So the newest one was trained on 4 terabyte of tokens, resulting in a model of 15 billion parameters, which would be almost equivalent of 15 gigabyte in size. And it can speak 600 programming languages. And the cost to train the whole thing, because they need a lot of dedicated hardware for that, was 2 million. And this one you can just go download if you want to use it. That's a very nice thing. Okay, now, how can it help us in our daily work? This is the software development lifecycle in Lize flavor, because I've added documentation, which people seem to forget, and it's so important for everybody who is going to touch your code after you. So if we look a bit at the aspects we have there, in the analysis, requirement analysis, and the scope, we can actually use ChatGPT if we are allowed, or some local version already very well to go from these vague customer requirements to what are the real technical specifications here. And something that's very nice is that it will catch edge cases for you if you ask it to. So you don't have to find out while implementing that, oh, this whole edge case was not specified. So it can save you time later down the road. It can also help you with making your documents for legal, with making the documents for the developer, for the customer, as variants of one of another. Then design and architecture, it's very nice for brainstorming, to know what's out there, to see which dependencies to use for whatever it is you want to do. And then in implementation, in the coding itself, it comes in quite handy. So this is a graph showing the most popular programming language by decades, saying that in 2030 it might be English, followed by Mandarin, and so on. I think this might be true. I think this might happen before 2030, but I also think we're always going to need specialists to hang the whole system together, right? Even if the code is written, most of the code is then written by AI. So it's going to stay this mix, I think. Now, as we think coding assistants, we probably think GitHub Copilot or IntelliJ AI assistants, but they work fine for certain use cases, and then when it gets a bit more complex, they fail. And so people are working on making them smarter with very smart approaches like using knowledge graphs of your code to inform the model, and then you can ask very different questions about your code and go look through your entire code base very efficiently. This is work in progress of a team at Deutsche Telekom, so I'm really curious what's going to come out there once they're ready. Another example, which you should know about, is Devoxx Jenny plugin. It's created by Stefan Janssen, the organizer of Devoxx Belgium. And the nice thing is, let me see if I can show you somewhere. Yes, so I have it running here. I cannot make it smaller, but you can pick a lot of model providers if you have a key for them or if you have them locally. So I had Olama here with Phi3 selected. And then you can ask questions about your code, but you can also ask it to explain, to generate unit tests. And it's work in progress, so there's always new features, nice new features coming along. Why you would want to use this and not GitHub Copilot if you're working for an employer like me who works in a regulated environment and our code is kind of our IP. They don't want us to have that sent in GitHub Copilot, so we really have to work locally, and then something like Devoxx Jenny is really a good solution. Okay, this is one that I'm very enthusiastic about. It's absolutely not local, but it's an AI-first code editor called Cursor, and you can just go download it, install it, and I will show you it works amazingly well. So here it is. So I have here an application open. That's a feedback analyzer. I have put a print screen here because I don't want to get it up running. But first step of is that you can enter feedback and some fields. And then what's going to happen, it's an AI-powered application that's going to take your feedback, split it into coherent parts, which you see on the right side there. And then it's going to do a certain analysis and tag it and categorize it automatically. So you don't need people to do that anymore afterwards. And then there's also a whole dashboard side where you can go interact with that feedback and explore it in a smart way to get really an overview of what people think. So what I want to do here, something that GitHub Copilot would definitely fail on, is I want to say add a field profession to the web form after the field gender, and make sure to use it throughout the rest of the app, just like the gender field. Because, I mean, it's typically something that happens to me. Oh, I want an extra field, basically, but then it has to propagate to the dashboard and to the backend and everything. So here I can select with the entire code base, and then what it's gonna do is index my whole code base, kind of put it in a database in a way that it can really easily find related parts. And then what it tells me is, good, we start with updating our data transfer object by adding profession here, and I always need to check if this makes any sense, right? Just don't blindly believe it. But it looks good, a getter and a setter, so I'm going to just apply. Then it needs to think a bit, and it opens my file for me, and it puts these changes right there, and I can say, looks great to me, I'm going to accept this. And then also feedback.html I would have to update. Looks also good that I should add a field, of course. I'm going to apply that. So it opens this file. Now it works a bit. So let's go have a look. It added my field here after gender, like I asked. And here, it stores it also in my data object. So I'm going to accept, and so on and so on. So as you can see, it finds all the places where I have to make a change, proposes the changes, and I can just apply. And I find this really, really amazing. Good. So that was Cursor. I've not seen anything work so well as this one. Good. You may have heard of software agents like Devin. There was like this very short hype, but then it turned out to not do such a great job. Now, just to let you know, again, it's a field in progress. So what they do is they let an LLM decide how to work on your code. And they give it access to your file structure, to open files, to scroll up, scroll down, to search, to make edits, to run, to check what's the output. So if you give an LLM enough tools, it can start doing this whole cycle for you. But the nice thing is, Princeton University, they made an open source version called Software Engineer Agent. You can go check it out on GitHub or just watch a tutorial on how it works, and it scores almost as good as this commercial Devin. The nice thing is, like if you have some assignments on Upwork, it actually can already solve a couple of them by itself. So definitely have a look into that. If you want something concrete for your project, if you're using GitHub, you can add CodeRabbit AI. That's a pull request reviewer, AI-powered one. It gives really nice suggestions and also apply diffs with the solution. And what it usually is, it doesn't find a couple of things that I say, I would do this differently. But then it finds a lot of other things that I wouldn't have spotted. So I think it's like a kind of pair programming with AI, and it's very helpful. Another tool on GitHub is Dozebot. This one helps you with issues, discussions, and I think bug reports. So whenever somebody opens one, after a while, Dozebot goes and have a look in your code and tries to solve it or tell where the issue comes from. And sometimes it's just impressively good. Sometimes these problems are really not trivial, and it still points you to the right place. So those are free tools that you can already install today. And then this documentation, yeah, we all don't like it, but we kind of all need it, and then we make it code change, and then we actually need to propagate it to the documentation. I didn't find a tool yet. If you found one, please let me know. Get in touch on LinkedIn. But I just dream of a tool that, like, you make a code change and it tells, like, okay, I think you should update the documentation here, apply div, go. Good. Then when we move on to testing, it can generate these unit tests, not perfectly, but it helps you a lot, making sure you catch all the edge cases and with this very repetitive code. But also if you do integration testing, for example, Cypress, the syntax is just so hard, and you know what you want to do, and it's so hard to make it do it. There's exactly where LLMs are really helpful. If they've seen you do it a couple of times, they can just mimic it and really help you moving on with that. And also for synthetic creation of test data, it's really nice. There's already a lot of companies that really make this their business to sell you synthetic test data also for things like exactly the bioinformatics where I work in, where all this clinical patient data is very protected and regulated. You can start using synthetic data now. When it comes to deployment, our IT people and our DevOps people are so happy with any ChatGPT-like tool because they're dealing with new operating systems, new server setups, new things every day. And that's where LLMs come in super handy to get you started on something you didn't know anything about. And then for maintenance, they are working on tools that, let's say, automatic log file analysis, for example, to go see if there are bugs, automatic categorization of your bugs. LLMs are in principle smart enough to say where probably in the code the bug came from and to actually assign it to the right developer that was working on it in the first place. Again, these tools are coming, and it's going to be very nice when they're there. And this is a little exciting project of Red Hat. They try to predict what's going to be our next move. So instead of predicting what's going to be the right code, they're going to predict what the developer's probably going to do next. Where is he going to click? What is he going to do? And I feel these days very much when I'm doing I'm coding, I'm running it, I'm looking at the result. It's not what I want. I'm going back to my code. And this whole cycle, I think, like, it's so predictable what I'm going to do next. Like, of course I'm going to run it. Of course I'm going to go and have a look. I would be very happy if AI just says, oh, are you trying to do this? Yes, boom. And so it's again, it's work in progress. It's still proof of concept. But I think these things are coming. Then just to let you know, Atlassian brought out Rovo, which wants to help you with this complete software development lifecycle, so you can integrate all your Atlassian products, Bitbucket, Jira, all together, and it's gonna try to suggest you what ticket you want to create, who you want to dispatch it to, which code you want to change. I still have to test it out. It's still with a waiting list, but it's promising. And again, even if today it's not great, I think in 2 years from now it's going to be excellent and extremely helpful. GitHub Copilot has their own version, Workspace, also with a waiting list. I just got accepted, so I will be playing around with that this weekend and see how good it actually is. Good. So what we want to watch out for? We're not going to just start throwing AI at everything, because we have to keep in mind that we might, as Kevin Henney stated here, we might find ourselves in the end in a role that we actually were trying to avoid, the one of having the code creation automated, and our job will be debugging and fixing this code / legacy code. And that's maybe everything we don't want to be doing. So we should be a bit careful there. And then another graph, but it went only to half of 2022, so I'm really curious if they would rerun this experiment. This is the code churn. That's a measure to say how often your code has been changed in a certain time frame after it was written. So it's bad, because if you wrote code and within 3 months after you've already changed it 5 times, it was probably not great code in the first place. And they saw a light trend of seeing this go upwards from 2022 on. And then the question is, but again, it should be verified if it's really doing this now, if AI makes the code churn higher, because it's in the end costly to have to go back and change your code. Now, how about the climate? Say 1.5 years ago, these models were huge. They're eating up a lot of resources. They still do. If we start throwing AI at everything, it might be very costly in terms of electricity and hardware. But then, at the other hand, we see that the model size decreases orders of magnitude for a similar quality. And so does the cost drops also. And if this continues in the end, these tools become also somehow efficient, because if they save your developers so much time, so much kind of less time that their computer has to be on, in the end it's a balancing act. And given this progress, I think this is pretty fine right now. For example, we are running a coding model for our developers for auto-completion in our company on a small GPU gaming server. And we serve about 200 devs for 100 watts, 200 watts, something like that. So that's actually quite efficient, and it makes them much faster as well. Okay, now, will AI solve all of your problems? So you can compare it to duct tape. A lot of people say you can fix everything with duct tape, and if not, then you just have to use more. And at first this seems true, because you can paint your car with the duct tape. You can tape your boobs together with duct tape to look better. You can fix airplanes with it, and then they're ready to go to the moon. And it's also a great parenting hack. But apparently duct tape is not the solution to every problem. It's the same with AI, right? So use the right tool for the job. We already have a lot of tools that could be a kind of replaced by AI, but maybe we don't need to, right? Like linters, like your dependency vulnerability checks. We already have great tools for them without AI, and they're like faster and cheaper, more optimal, more deterministic. So just keep AI for the things where you really need it. So today, best applications is code writing, changes to code that's not spaghetti code, that has 20 references to it, but somewhere at the end of your thing, it's great to use. For testing, test generation and test data generation, it's cool. For helping you with anything that's unfamiliar to you, and for big searches on data lakes. And that's actually a major positive thing, because people in knowledge jobs spend about 20% of their time searching for things. That's 1 day of your week, and AI can help a lot there. But then, where you don't want to use it today is changes to spiderweb code, so code that heavily used and referenced everywhere else, is going to break things if you use AI these days. Refactoring, it's a mess. Don't. For now, do not. And generating complex code over multiple classes, it's also not doing a good job yet. But then again, I think it's going to come because the progress in the field is huge. Now, what can we build on top of AI? Which products can we build now? So this is the AI application stack. The good news for you is that, oh yeah, there's an A missing with data, but there's this data layer. There's a lot of work there that data engineers do to get your data clean in order to even start training your model on top there, the green layer. There's also a lot of work in training a model correctly and maintaining it and re-evaluating when the data changes. Good thing is that you can ignore about all that for now. That's data scientists' job and specialty. We just stay up there in the application layer, and we are going to use these models as any other API. An API with a certain latency, yes. With a cost, yes. But we don't have to care about this whole ML ops, machine learning operations. We just stay in our developers and DevOps space and use the models. When you want to build an application on top of AI, just remember there's these days models that can predict anything. And if it doesn't exist what you want it to predict, if you're lucky to have a data scientist in your team, then you can team up and they can maybe find data and train it. The examples you see here is on the left, a model that predicts how your hair will fall and move. So that sounds funny, but then when you know that for a Disney movie, there's a whole department at Disney spending months and months for making nice hair that looks natural. And so now we have models to predict this. I mean, I don't know how good they are yet, but definitely progress there. And the other one is Depth Anything, which is an open source model where you can send in images and video, and it will extract all the depth values for you. This is super nice in modeling and simulations to have this depth information. Okay, so then once you have the model you want to use to build something on top, how do you actually use it? So typically it's going to be via API. Somebody's going to provide you the service and to run it. But you can also directly access the hardware of the machine you're running it on. And this is just a little side excursion here, but I like this so much. In JavaScript, you have a tool, web GPU, to allow you to access exactly the user's GPU. So I can show you that. So this is Nico Martin. He made this little program that you can go test. Infinity mirror, I love it. So let's wait for a bit. It should detect my face at some point. Not today. There we go. Right. So now this is an AI model predicting how my face moves, but as you can see, it's not fast. It has 5 frames per second. That's because we're using just a normal CPU. But we can use this web GPU, and oops. Now it's already much better, right? Now it has over 30 frames per second on my MacBook. It's of course using a lot of resources, but it's really nice. And why you want to use this is for great applications like this one. We've all been dreaming of this, right? Okay. Good. Now, if we want to do it in Java, but again, like I'm mentioning this JavaScript example because maybe you don't even need to do it on the backend at some point. If you want to access GPU in Java, there's a lot of very nice projects going on, like Tornado VM to directly talk to your GPU, but also Project Panama, which provide much more direct access to native resources. And then one that's also really interesting in this context of AI models and calls is Project Loom with the virtual threads. Because these calls are so high latency, you will want to put them on a virtual thread while you're waiting for the answer if you have a lot of parallel calls going on. Okay, now where would you want to use AI for your application, or in existing applications? Where can you already use it very well? It's for editing user experience. So I'm so fed up with these web forms where you have to select your nationality from a drop-down of 200 things. And I'm from Switzerland, so I type S, and then I get a whole page of R, and then at the end is the first country with an S, and I'm just like, I want to kill someone. So here you can use a chatbot instead. Yeah, I don't have time to demo it now. But you can instruct a model to know what it has to ask for, what role it is, your company policy, and then I have an example where you want to cancel bookings, and you can put in there, it asks you for your username and for your booking code, and then it goes search that in the database because it knows it needs it. So instead of having to fill out a whole form with my address that they don't need anyway, you can have chatbots ask for really what is needed for this user, and then put them directly on the right track, like, oh, this person wants to cancel the booking, so we don't need all the rest, and then you go on there. It's a huge breakthrough there. Also, it can then be in the user's own language, because most of the models are multilingual, and also they adapt. Like if you're going to search on, say, my local government has some subventions, and I want to check if I can apply there, it's this messy lawyer's language, and like even I have a hard time, let alone people like my granny who may struggle even more. And again, there, chatbots help you to phrase it on the level of the user very well. But it's more than just chatbots, right? So formatting data, there AI does an excellent job. If you're struggling with big unstructured data, or you have two formats and you want to go from one to another, like you can either let large language models do that, or you can let large language models generate the code to do it for you. Parsing anything, as you could see, this whole text where we extracted the date from, but also for generation of content, marketing content, but also, for example, psychological advice. So I made a couple therapist with my partner that takes in both our feedback and then gives us a working plan for us together. You can also use it for that. And then this analysis, as you saw in the feedback analyzer, it can do a good shot at analyzing vast amounts of data. Just a little side note on this is Google Amy. This is a model that Google trained to help with medical diagnosis. And I want to just show this to you because it's so good. Like, these models are getting so good, so we will want to build applications around it. What you can see on the right is how doctor scores in this purplish, and then in the pinkish, how good the Amy chatbot scored. And as you can see, it outperforms the doctor everywhere, even for empathy. So it doesn't have a bad day, and it is not biased towards whoever sits in front of the person. So that's really nice. And then even worse on the left, in blue is if the doctor tries to put the diagnosis alone without any help, so the diagnosis accuracy. In green is when they can use any search tool. In yellow is when the doctor can use Amy chatbot to help him with the diagnosis. And in red, if it's Amy alone. So the doctor, with all his experience/bias, actually makes it worse. So I actually want someone to wrap up Amy in a tool that I can ask my medical questions to. I would trust it in the end more. Sadly enough, it's not published yet, so but I think it's going to come. Good. So where are we heading to? What we see is that the models get better quality while their size and the cost to use them is dropping. They're hallucinating less, and people are putting all kinds of checks in place to make it more deterministic and more correct. We see also very small dedicated models coming up. For example, embedding models are one of those where you're going to put text into small vectors that encode the meaning, and they have a very specific use case when you want to try to find related data. But there's many more of these very tiny dedicated models. They're super fast, super cheap, and super good at what they want to do. So I think the future is more not one big LLM, because it's kind of way too smart. It's really overkill for a lot of things. I think we're going to have a lot of very small dedicated models that are going to work together to solve issues. And we see this trend for on-device AI. So we've been hearing it lately. Apple has been adding it. Microsoft, like they're putting AI-enabled chips in virtually any device that they make these days. And with the models getting smaller, it's really a very cool match. And the nice thing is that it stays on your device, so for data privacy, that's really nice. Here you see a graph, how AI has caught up with the human baseline there at 100%. So first, image classification surpassed humans like around 2015. Then came basic level reading, then came English understanding and visual reasoning, and they've all outperformed humans at this point. The last one you see going up there is competition level math. As you can see, they're catching up with what humans can do, and they're catching up ever faster. So it's from Stanford University. They have this little quote: as quickly as things are moving, each year is likely going to be magnitudes crazier, whether the world is ready or not. And we see it already happen today. So, my time is up, so I'm just gonna say one last thing about will AI steal our jobs? So the answer is no, not on the longer run. Will we all have a 4-hour work week now because AI does all our jobs? The answer again is going to be probably not, unless if we really insist. But we've seen so many big revolutions where machines, say steam engines, could take over a lot of the human work that had to be done in that time. Then it takes that over, and then somehow you see that people don't start working less. And okay, there's always a very painful period where people have to shift their skills. But then, I mean, the employment in the end is stable. And so why is this? What you can see on this graph, in white is what humans can do. In black is what machines can take over. So all these people will be out of a job. But around there, like endless space basically, is things that humans can do with help of machines that was not possible before, and that now becomes a new job. And that's why we see also for developers, I'm not going to read the quote here, but we have had so many tools available to get faster at things, and we've always needed more and more and more and more developers. So we're good. So last thing I want to ask you, we have now this superpower to work faster and to build new tools. We can abuse it to say, we automatically profile users and try to make them buy more stuff and get them into that better, and it's great for our company. This is not great for these people nor for society. So you can also choose to start building things that are actually helping, like democratizing education and medicine, and there's also a lot of cool things you can do with it. And I'm convinced that if you build what you love and love what you build, then you help shaping the world that you would like to see. So thank you very much for your attention.